Can Cassidy hear us right now? No, Cassidy's down in the library. I don't think she can hear you from here. I do know what you mean. Can the people on the video hear you right now? No, the microphone doesn't pick you guys up very well. Okay, if you yell loud enough, yeah. All right, so like I said, today we're going to start with the lesson, and then when I give you guys the assignment, you can either work on the assignment or you can work on the quiz, okay? I have optimism that we can finish this entire section in just one day, okay? It's only 15 pages, and the last page is always just like a summary that we never get to anyway. So there's two basic things that we're going to do here. The first thing that we're going to do is we're going to learn polynomial long division. Okay? Polynomial long division is difficult, slightly confusing, and only useful in some situations. Okay? Then what we're going to do is we're going to learn synthetic division, which I don't know if you remember, but I mentioned yesterday. That's one of my two favorite things along with the sign charts. Synthetic division is super easy, super fast, and super useful. Why, you ask, do we need to learn polynomial division then at all? Because there are a very few number of cases where we can only use polynomial division. So we need to learn that first. Okay? Are you ready? Okay, so the first thing we're going to do is we are going to review how you do, like, I don't know when you learn long division, 4th grade, 5th grade, 6th grade, long division. And I always get a kick out of this because every once in a while there's somebody in here who went to a different school. Sometimes there's an exchange student and they're like, that's not how you do long division. I had a gal one time, I can't remember what country she was from, but they did it upside down. So they did the things like, it was pretty wacky, but it's kind of cool. Anyway, so let's recall how we would divide 68,794 by 32. How did you come up with 2?
Because 32 doesn't...
Okay, so Sydney is focusing on just the first two numbers. How many times does 32 go into 68? Hook 'em horns, 2 times. So 2 times 32 is 64. So then I go 2 times 32, 64, and then what do I do with this?
47.
I subtract these, right? 68 minus 64 is 4, and then you bring down the 7, and I got 47. Okay, slow down. Slow down. We're not all as smart as you guys. Okay, now you just repeat the process again. So now I'm going to see how many times does 32 go into 47. McKenna, once. Then I multiply back again. 1 times 32 is 32. 47 minus 32 is 5. I bring down the 9, and I play again. Okay? How many times does 32 go into 59? How many times does 32 go into 59? Okay, time out. Shh. Time out. What? Oh, because they're, okay. I'm like, why are you guys saying these huge numbers for 59? Thank you. Apologies. How many times does 32 go into 159? Yeah, 5 times 5 is 160, right? So it's just less than that, so it's 4. So now 4 times 32 is 128. I subtract those, makes that 31. Thank you. Bring down the 4. So how many times does 32 go into 314? You're like 9, yeah, probably, because 10 is 320, right? So I go 9, and then 9 times 32 is how much? 288. So if I subtract that, it is 26. Okay, so there are 2 different ways that I can write this now. I can either say it goes in like this with the remainder of 26, okay? Or I can say that 68,794 equals 32 times 2,149 and 26 30 seconds. Okay? So we also sort of, in the process of doing this, and this is how it relates to our lives, we sort of factored this into these 2 pieces. Okay? And so that's what we're going to use it for. If I multiplied 32 times 2,149, I would get something that if I added 26 to it, it would be this. Okay? All right, so we're going to do that same process, but we're going to do it with polynomials. So if you're a note taker, this is the time for you to take notes. If you're not a note taker, become one. One of us. One of us. Christian, Cooper, I'm talking to you. Write this stuff down. Okay, so just like Sydney started us out with the other thing, she didn't try to figure out how many times that it went into the whole thing. She just looked at the very beginning. So what I'm going to say is, how many times does x go into x cubed? Well, that doesn't make any sense. But when you say how many times does something go into something else, you're really saying, what is this divided by that? So what's x cubed divided by x? X squared. Okay, so an x squared goes right there, because x squared times x is x cubed. I just feel like you took the longest route to get there that you possibly could. Yeah, you pretty much have to. All right, once I figure out what goes there, what do I do next? Nope, in long division, what did we do after we put that number up on top? We multiplied it. We went 2 times 32 is 64. So now I have to go x squared times x is x cubed, and then I have to go x squared times negative 2 is negative 2x squared. All right, 98.6% of mistakes in polynomial long division are made right here, okay? Because what do I do now? You subtract, okay? So I have to go x cubed minus x cubed. Those will cancel. But then I have to go 4x squared, yes, minus negative 2x squared. So that's really adding those together, so that's 6x squared, okay? Because of that, pro tip, once you multiply through here, go and change the signs on this and then add, okay? Yeah, so make this a negative, make this a positive, and then just add them together, and then you don't have to remember that weird subtraction thing, okay? All right, and then you just do the same process over and over and over again, okay? So how many times does x go into 6x squared? In other words, what is 6x squared divided by x? 6x, so I'm going to put a plus 6x up here. And then I multiply back through. So 6x times x is 6x squared. Oh, I forgot to bring down the negative 5x. So that's 6x squared, yeah. And then 6x times negative 2 is negative 12x. You can, if you want, just try and remember to subtract. But again, my suggestion to you is to change the sign on both of those terms and then just add them together. So 6x squared, negative 6x squared cancel. Negative 5x and 12x make 7x. Bring down the negative 14. And let's play one more time. 7, yeah. 7x divided by x is 7. So 7 goes up here. Then if I multiply it back through, you notice that I get 7x minus 14. So when I change the sign on these things, everything cancel, and that gives me 0. All right? So 0 means, for one thing, there's no remainder, right? And that also means, more importantly for us, what we figured out is that this divided by this equals this. There you go. Which means that I could write this as x minus 2 times x squared plus 6x plus 7. What Sydney said is 100% correct. When you get no remainder, that means that this is a factor of this. Okay? All right, any questions so far? Yeah, exactly. So you only use the very front term of this, and you only use the front term of this. And then the other part comes in when you multiply back through. That's exactly correct. Yeah. Yes? Well, this one only has one way. Well, this you could write it like this, like that whole thing. Or you could say x cubed plus 4x squared minus 5x minus 14 equals, x minus 2 times x squared plus 6x plus 7. Okay?
You have to plug that into that?
No, it just said divide. We divided. It's done. This is the answer. X squared plus 6x plus 7.
Oh, never mind.
Ma'am?
So both of those things.
Both of these, all of this nonsense here and this shorter statement here, well, I guess it includes this over here, mean the same thing. Yep. Okay? All right. So how is this useful? We came across a problem when we were finding horizontal intercepts in the last section. I think it was maybe 2 or 3 days ago, where I said we cannot factor this. Okay? So we went to the graphing calculator, or to Desmos, and I said there is a way for us to factor it. We're going to learn it later. We just don't know it yet. Now we know it. Okay? So if I want to find the horizontal intercepts of this, I have to set it equal to 0, right? And then I need to solve that by factoring. Well, guess what? We factored it just now, right? This thing right here is the same as this thing right here. So we know that we can factor this into x minus 2 times x squared plus 6x plus 7. Okay? So now we've broken it down into two much easier problems because I am going to fall over one of these days. If x minus 2 equals 0, then x equals what? 2. Okay? And then this is only a quadratic. So we have 3 different ways that we can solve this. We could try and factor it, but sadly no two numbers multiply together to be positive 7 and add to be 6. If we were feeling a little bit wacky-macracky, we could solve this by completing the square. Okay? But no, nobody wants to do that. So our third way is quadratic formula. Right. So to figure out this piece, I'm going to go opposite of b plus or minus the square root of 36 minus 28 is 8, all divided by 2 times a. Okay? And now I have solved this without the use of our good friend Desmos. Okay? It's so crazy it just might work. That's a great question, and you deserve some dojo points for that. Dylan recognizes that I kind of tricked you a little bit, because he's like, how did we know in the first place to divide this by x minus 2? Okay. You were thinking that too? Yeah. Okay. It just coincidentally is in the last problem, but if I give you like something out of the blue, you're not just going to go, oh, let's try x minus 2, right? Okay. There is a way to find this. We're taking baby steps. Okay. We'll get to that later. All right? Okay. All right. Here's a fun question. Oh, nope, never mind. Do this one on your own. Cassidy, I'm going to pause the video for you to give you time to work through this problem all by yourself. When you're ready to go again, please press play. Okay, so the first step, I have to write it in this dorky way. And then what did you do first? Oh, I know what happened. Okay, so what do you do first? 2x squared. All right, then when you multiply this back through, that gives you 2x cubed plus 6x squared, right? Okay? Right. So yes, I can only combine like terms here, right? So I'm going to change these both to negatives and then add. 2x cubed minus 2x cubed cancels, but then there's 0 x squareds here. So this is actually going to be negative 6x squared. And then I bring down the negative 7x. So it would have made our lives a little bit easier, and this is something to remember in the future, if we had recognized that there was no x squared. So we could have gone 2x cubed plus 0x squared minus 7x plus 3, just so that we would know that these need to line up with each other. Okay? Cooper? What if you just plugged in 2x? So I was trying to avoid the question I didn't know the answer to by answering a different question, but that question I don't even understand what he's asking. So now I'm kind of stuck. What do you do next? Oh, okay. How many times does x go into negative 6x squared? Negative 6x times. Negative 6x squared divided by x is negative 6. I just threw it in there to hold the space for the x squared so I wouldn't be confused when I have an x and a 6x squared like lined up together. That's what Dylan was asking, like where did that come from? What's that called when you write it like that? And I don't know that it has a name like expanded form or something. I don't know. What did you say? Plug in 2x?
0x squared, and it'll make sense.
Okay, so it's gone. Now, plug in 2x to what?
No.
Okay, so this is negative 6x, so I multiply those together. Negative 6x times positive 3 is negative 18x. So I'm going to subtract those. So to remind myself that I'm subtracting, I'm going to change the signs on both of these. So negative 7x plus 18x is 11x. Bring down the 3. Okay, and then this time, cats and kittens, ladies and germs, we're going to end up with a remainder because what's 11x divided by x? 11. So if I multiply this out, then I get 11x plus 33. Change those into subtraction, so we get some canceling, and then we get a remainder of negative 30. What? Hang on just a second. I'm going to try and understand Cooper's question.
Instead of having 2x squared, right?
Okay, in the very beginning,
Put in 2x.
Put in 2x for what?
Multiply x plus 3 times 2x.
Oh, okay, so then you get 2x squared plus 6x.
Right.
And therefore,
Right. And then 2x to the third power, subtract 2x to the second, which is x.
nope, it's not.
It's not.
No, you can't combine them. They're not like terms. Okay. Now you were almost onto something really brilliant. Okay. You were almost onto something really brilliant. Okay. Can you guys take a second, please, and plug in? I know this is going to seem really random, but it can't be any more random than what Cooper just did. Will you take negative 3 and plug it into this right here? Where did I get? Yeah, just plug it. Yeah, exactly. Make it x, and then tell me what you would get when you plug that in.
30,
Negative 30.
Yes, that's remaining.
Okay, right. And so it would have been like a minor miracle if that's what Cooper was getting towards. Where did the negative 3 come from? Yeah, because I need to make this equal to 0. So x plus 3 equals 0. That means x equals negative 3. So it turns out that the remainder that you get when you do this division is the same as what you get if you plug that number into the original function. Okay, a really handy but little used fact. So like if you're trying to evaluate a thing and plug in a thing, you don't have to, no, never mind. You don't know yet. So that's called the remainder theorem, which is that the remainder is the same thing as what you get when you plug in the number. Okay? So what this crazy mumbo jumbo says it means is P of C is the same as the original polynomial divided by x minus c, the remainder of that. So if you take the polynomial and you divide it by x minus c, the answer that you get is the remainder, is the same as what you get if you just plug the number in. Okay? All right, you guys feel okay about that? What c? Well, it's the number. It's in this case c was negative 3. No, it's the thing that's being subtracted from x. Yes, exactly right. So on the very first one we did, c would be 2. So you can tell me, you can all tell me right now, without even thinking at all, like just boom, what would you get if you plugged 2 into this whole big polynomial? 0, because we had no remainder. So if I plug 2 in there, I would get 0. And then same thing here. If we plug -3 into here, we would get -30. Okay? All right, is that good enough for you guys? Have we done enough? You want to practice this a little bit? Because some of you guys need to finish your quiz, right? So I want to make sure you have enough time for that. All right, so sadly we didn't get through the whole assignment today, but I'm going to try and pass the quiz. That's a good idea. Oh, right. Okay, it's pretty easy stuff because that was the hardest part. What we do tomorrow is really, really simple, yeah. Huh? What you're, yes, yes, yes. Cassidy, look out behind you. Oh, just kidding. Okay, so really short assignment because like I said, I know some of you already have other stuff to do. Will you please